Okay, Assalamu alaikum guys. This is Abdi Muhammad Noor who is back in action now. We are going to discuss about form 3 concept of chemistry. Remember in our previous class we have discussed about division and Grahami's law, where we have derived the formula of getting or comparing the rate of division of gases. Today's class will be questions based on Grahami's law of division. We are going to see questions from KLB and as well as questions from the med familia, chemistry med familia, past questions of Kcse, okay? So that you are very much familiar with the questions of Kcse, and then you will not have any problem when actually solving problems related to this kind of concept of chemistry. So to start with that, let's say this is example 1. We have our example 1. You are told equal volumes of carbon dioxide equal volume of carbon dioxide, okay, and carbon dioxide are allowed to diffuse through the same condition, okay, through the same medium, let's say medium, yeah? Full stop. So you're told calculate the relative rate of division. Calculate the relative rate of division of carbon dioxide Now in the bracket we have, inside the bracket we have C is equal to 12.0 or oxygen is equal to 16.0. Now when you want to solve such kind of question in Kcse, you are told equal volumes of carbon dioxide and or carbon monoxide and carbon dioxide are allowed to diffuse through the same medium. Calculate the relative rate of division of carbon dioxide. In the bracket we have, inside the bracket we have carbon 12 and oxygen 16. When you come to the solution part here, you are going to get what you normally call the relative molecular mass of each one of them. So we are going to say relative molecular mass of the first one, which is carbon dioxide or carbon monoxide, okay? This will be 12 plus 16, which is 28. Don't forget that. Because carbon is 12 and oxygen is 16, so add them, it will be what? It will be 28. Then we will also look for relative molecular mass of carbon dioxide, which is written as of carbon dioxide. So that will be 12, which is carbon plus 16 times 2. So that will give you what? 44. Okay, come in here, but say like this. But what we know is, say, but rate of division of carbon monoxide or carbon dioxide or the rate of diffusion of carbon dioxide is equal to, be very keen here. So we say equal volumes. The moment we say equal volumes, I think what this is the formula we're going to use. Of course, in our previous class, remember, we have also discussed how to derive this thing, but for today's class, we are solving questions. Remember, it's equal to the root of the molecular mass of carbon dioxide, which is CO2 divided by Mr, which is the molecular mass of carbon monoxide. So here, this is what we have. Remember, we are going to say rate of CO divided by rate of CO2, which is carbon dioxide, is equal to what is the relative molecular mass of carbon dioxide? 44. 44 divided by the other one, 28. 28. Then into root. So this will give us what? Rate of carbon monoxide divided by rate of carbon dioxide is equal to, then you must have your calculator. Okay? This is our calculator, don't forget. Now, let's get the square root of 44. First say 44 divided by 28. That will give me 1.0. This will give me the square root of 1.5714. Then get the square root of that. Say root our answer, it will give us. So this is equal to 1.254. So we say in chemistry, remember when we compare with respect to the relative molecular masses, when we compare the rate of diffusion of carbon dioxide and carbon dioxide will diffuse faster than carbon dioxide, simply because the gas with the less relative molecular mass diffuses faster than the gas with a large relative molecular mass. Don't forget that, because the lesser the relative molecular mass of a gas, the higher the rate of diffusion. So we can say now, this means that look here, this means that carbon dioxide diffuses 1.254. Yeah, diffuses 1.254 times faster than carbon dioxide, because you say that the lighter the gases, the higher the rate of diffusion. Just understand that. Okay, so you can say this means that carbon dioxide CO diffuses 1.254 times faster than CO2, which is carbon dioxide. So that's how you're going to solve such kind of question for your information. Okay, that's how you're going to solve such kind of question for your information. Then let's go and see another example from this book. Then we'll go to Kcse questions. Okay, I think this is a very nice question, by the way, which will help you during a Kcse. Make sure you solve this thing. Yeah, solve this thing. So we will immediately proceed to example 2. We will proceed to example 2. Just understand that. Okay. We will proceed to example 2. We will go and see example 2. Okay. In our example 2, look here. This is what we are having, by the way. Let's see this one. Example 2. This is our example 2. We are told if it takes 20 seconds, for 200 centimeter cubic. Remember, this is 200 centimeter cubic. That's the volume, yeah? of oxygen gas to diffuse across a porous block, then that must be full stop. How long will it take? An equal volume of sulfur oxide to diffuse across the same block. Question mark. Okay? Here, when you look at this question now, we have for oxygen now, let me write that solution to this problem. Oxygen gas, for oxygen gas, I have what? I have time. Time is 20 seconds. I have also its volume. The volume is what? 200 centimeter cubic. Okay? But when you go for sulfur oxide, what we have? We have equal volume. Okay, look at that. Equal volume. So they have equal, because they say look here, go back and read this thing. How long will it take? An equal volume of, that means the volume will be 200 centimeter cubic. But what's under question mark is, let me write that. Time taken by this one is under question mark. But volume V is the same, because equal volume. Okay? Just understand this thing. For your information now, in this question, when you look at this question now, these are equal volume of gases for your information. Okay? So what we are going to do is, this is the case. For now, I can solve in two ways. See, I can solve it in two ways. First, I can get rate of diffusion of what? Rate of diffusion of oxygen gas. I can say, look here, rate of diffusion of oxygen gas. I'm going to say rate. Rate is equal to volume divided by time. Don't forget that. Volume divided by time. So I can say, which is equal to 200 centimeter cubic divided by 20 seconds. So cancel. So that will give me 10 centimeter cubic by second. So that is the rate of diffusion of oxygen gas. But what I know is, from read the question out, we know that we can say now time taken by oxygen gas divided by time taken by sulfur oxide gas. Okay? Because the two gases you're having is what? Sulfur oxide and the carbon dioxide. Go back to the question. Is equal to, can say, molar mass of oxygen gas over the molar mass of R of SO2. Okay? The molecular mass of SO2, because we have both of them there. So remember, oxygen is O2. So O is 16 times 2, that 2, yeah? Don't forget. So we can say, remember we can say, look here. See, you can also get that. we can say that, we can say, let me get time, yeah? I can say time for oxygen is what? Change. Divided by time of sulfur dioxide is equal to 16 times 2 is what? That 2. Divided by that 2 plus that 2. Because sulfur is what? Sulfur is that 2. These guys are not given as such, but remember you can place here in the bracket you can say O is equal to 16, comma, S is equal to that 2. So now when you have sulfur dioxide, S is that 2, O is O2, yeah? That's what? 16 times 2 also that 2. So this will give us 64 into root. Okay? 64 into root. Okay. Now, what we are going to do is actually, what we are going to do here is, let me get this one. So this will be a half, I think. A half into root, because by the 2, 1, by the 2 is 2. So I will have, okay, I will have 20 out of T, SO2 is equal to the root of what? 0.5, which is half. So let me get that. Root 0.5. So this is what? We can say this is equal to, look here, we can say 20 out of TSO2 is equal to 0.7071. So what are we going to do? We cross multiply. We multiply here TO2T. Then we can say TSO2 is equal to 20 divided by 0.7071. So that will give us 20 divided by the answer, our answer. That is, you see now, that is 28.284 seconds. So you can even stop using the rate. The rate is not that much significant. You can do away with this part because using this one will give you the time, okay? So that's how you're going to solve such kind of question. You can leave this part, but there will be a time when you're going to use this kind of concept, of course. That's when you're going to see when you can use this one, of course, okay? So that's how you're going to solve for your information, guys. That is example 2 for your information, guys. Then I will proceed to Kcse questions, guys. Then we are going to solve those ones. Example 3 will be a question from made familiar of Kcse chemistry. Okay, let's see that. Make sure you take your time, follow me. Make sure you have your pen and your book, then you solve with me everything. Okay, that's what we are going to do then. Okay, now let's proceed to made familiar and solve questions from Kcse. Okay, this will be our example. Our example what? Our example drip. Look here. This is our example drip. So you're told 6 centimeter cubic. 60 centimeter cubic of oxygen gas. Of oxygen gas. Of oxygen gas. Diffused through a porous partition. A porous partitions in 50 seconds. In 50 seconds. Full stop. How long would it take 60 centimeter cubic? How long would it take 60 centimeter cubic of sulfur dioxide? Sulfur dioxide gas to diffuse through your tongue the same partitions Look at this one. Partition. It's not that much significant. But under the same condition. And the same condition. Okay, this must be a question mark. Then here, we have, in the bracket we have sulfur is equal to that 2, oxygen is equal to 16. Close the bracket. Okay, let's see now. Let's see how we're going to solve such kind of questions in Kcse. Okay? Let's see now how we're going to get such kind of question in Kcse. So we have the two gases here. One, we have oxygen. Oxygen, we have volume 60 centimeter cubic. Then we also have what? We also have time taken. Time is what? Time is 50 seconds, yeah? Then the other gas we are having is what? The other gas is also sulfur dioxide. Sulfur dioxide. For this one, you are told volume is also what? V is 60 centimeter cubic, but what's under question mark is what? It's time. See, you can also use the same procedure because they have what? Same, we have what you normally call same volume of gases, okay? Okay? So what are we going to do then? We will solve like the previous one, of course. You can also say time taken, look here, time for oxygen gas. Let me come to this point here, because there's a relation line. So we have time taken by oxygen gas divided by time taken by sulfur dioxide gas is equal to, this is what you're going to say, mR of oxygen gas divided by mR of what? mR of sulfur dioxide gas. So what you will do is we have time taken here as what? As 50. So you're going to say 50 all over T SO2 is equal to. So far volumes are equal, you can leave it, of course. You ignore them. Is equal to the root of oxygen gas, which is that 2 divided by, then this is also 64. Okay? Please make sure you understand this here. This will be how much? Just like the previous one, this will be 50 all over T SO2 is equal to that 2 divided by what? 64. That's a half. Into root will give us what? It will give us 0.7071. Then you cross multiply times T SO2 times T SO2. Cancel these two. So we'll have 50 is equal to 0.7071 TSO2. Then to get TSO2, we're going to say 0.7071 divided both sides by 0.7071. Cancel. So T time taken by sulfur dioxide gas is equal to 50 divided by the answer, the final answer here. So that will be 70.71. It gives us 70.71 seconds. Yeah. Okay. So that's how you're going to solve. So far, volumes are equal here. Just forget it. They're equal. Because it will not help you in the calculation. However, when you want to get, you can get rate from here, rate of oxygen gas, rate of revision. Then you can also solve in an alternative method. So this will be the last example. Example 4 will be our last example for your information, guys. Let us see example 4. Then I'm sure you will not encounter any problem in solving questions related to this kind of chemistry concept. I'm sure you will not have problem with the chemistry concept relating to this part. Okay. Now let's see another Kcse question. Let us see another Kcse question. Okay. Okay. We are told this is example 4. Look here, you are told state the Graham's law of division. Question A. State the Graham's law of division. Law of division. So that's carrying what? The question is carrying 1 mark. Then question B, under that you are told the molar masses of gases. The molar masses of gases. The molar mass of gases W and X are 16.0 sorry, and 44.0 respectively. Okay, full stop. You are told if the rate of division of W, if the rate of division of W, gas W, yeah? If the rate of division of gas W through a porous material, through a porous material is 12 centimeter cubic per s/h². That is the rate. Then, comma, you are told calculate the rate of division, the rate of division of X through the same material, okay. So actually we must divine coming to the solution part. You are told state Graham's law. Graham's law states that under the same condition of temperature and pressure, the volume of a gas is inversely proportional to the square of its density. So we must write that under the same condition and same condition of temperature and pressure, comma, the rate of diffusion of a gas, is inversely proportional to the square root of its density. To the square root of its density. That's the answer. Under the same condition of temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Okay. Here, when you come to question 2, you're told the molar masses of two gases X and W and X are 16 and 44 respectively. So you're told if the rate of division of W through porous material is this one, calculate the rate of division of X through the same material. So we are going to say, look here, we have rate of X. Is it W or X? W is the first one. So we are going to say rate of W over rate of X is equal to, look here, then MR, molecular mass of X divided by the molecular mass of W into here. So that's what you're going to say for your information. The molecular mass of what? Of actually W, and that will give us the molecular mass of, we reverse this one, the equal volume of gas, is it? So in our calculator, before we go and proceed with that, we are going to say, look here, this is what we'll be having. Okay, X is what? X is 44 divided by 16. Okay, so we're going to say MR over X, okay, MR over W, sorry, MR of W, because divided by molecular mass of X into root here. So we are going to say rate, but remember we have rate of W. Rate of W is what? 12. So we're going to 12 out of Rx is equal to, come here, 44 divided by 16. So this will give me 2.75 into root there. Root answer. So this is what I will be having. 12 out of rate of X is equal to 1.6583. Then to get this one, multiply here rate of X, here also rate of X. Cancel these two. So we'll have 1.6583 multiplied by rate of X is equal to 12. Then to get rate of X, we are going to divide both sides by 1.6583, 1.6583, okay, 83. So cancel. So rate of X therefore is equal to, say 12 divided by the final answer we have gotten. So that is 7.236, okay, centimeter cubic per second. So that is the rate of R, rate of gas R. Just understand that, yeah. So otherwise, guys, I wish you the best. I think I've tried my best. Make sure you go back and solve questions from Made Familiar as well as the KFB of Form 3. Otherwise, I wish you the best. Please make sure you subscribe our YouTube channel. It is an academic channel that will help you actually to get good grade in your Kcse. Otherwise, I wish you the best.